Hello, so today we are doing Leetcode daily challenge for April 7th. So let's get started. So the problem says we get an array of integers stones such that stones I is the weight of the ith stone. And we are playing a game with the stones where on each stone we choose the heaviest two stones and smash them together. And suppose the heaviest two stones have weights x and y, with x smaller or equal to y. And basically the rules of the game is that if both stones have the same value or the same weight, then both gets destroyed. If their weight is different, then the smaller one is destroyed, and then the remaining stone is basically has weights of y minus x, right? Which makes sense. And now what we want to do is, at the end of the game, there is at most one stone left. This is guaranteed. And what we want to do is return the smallest possible weight of the left stone. So we kind of want to maximize stones that are destroyed, or the amount that is destroyed, right? And we can return 0 if there are no stones left. Okay, so let's write this down. So our goal here is maximize destroyed amount, essentially, or equivalent to like minimize remaining amount, right? Okay. Okay, so we have this right here, and we combine 7 and 8 to get 1. Yeah, so basically, it seems like what makes sense is to pick the two largest ones, and then just smash those two together. So pick basically two largest ones, and then smash them together, right? Pretty much that. And just keep doing that. I think that should work. So for this, for example, we will do first 7 and 8, and then we will get remaining is 1, right? 8 minus 7, so we have only 1 remaining. We can delete this. And now we pick the two largest one, which is 2 and 4. So 2 and 4, remaining 2. So we have 2, 1, 4. 4 is no longer there. We have 3 ones. Now the two remaining ones is 2 and 1. We will get 1 remaining, right? And now we can smash these together, and it should return 0, right? So basically here 7 and 8, so we have 2, 4, 1. Okay, that's what I have there. 2 and 4, now we have this, and then 2 and 1 to get the array. Oh, okay, yeah, I have to delete this, right? And now we smash these two together and we have only 1 remaining, so that's what we return. Now the main thing we need to do here is actually just a way to get two largest elements each time. We can't just rely on sort, because then every time we add the difference here, in case they are when x is different than y, then we'd have to resort again. So to avoid that, we can just use a priority queue here. And in Python, that's just a heap queue. So I think we can do this with so how can we do this? So basically we can have a heap, right? And we can a heap queue in Python is a little bit uses only like gets you the minimum by default, and so to get the max you can just insert element with minus in front, because when the elements are negative, then the smallest number is actually the bigger positive number, right? And when we extract, we put negative, we put also the sign in front so that we get a positive number, right? And now we just need to add our stones. So I would be curious actually if heap q has an initializer with an array, so that we don't have to like walk through. It has heap push, heapify, yes. Transforms a list into a heap, that's what I want. So this would be just heap q, and here we can import, or I can just reference it directly. So here what we need is heapify stones, right? And now we can just say while we have two elements, right? Because if it's one, we want to return. And then here it says that there is at most one stone left. So it may happen that we have no stone left, right? And so now what we need to do here is return heap q dot heap, I think it's heap pop, right? Yes, so we need to do heap pop, and then we can return, we need to add this in front. The problem with this, though heapifying this, is that it will not be inserted with minus, so we can't really use it. Unless heapify, you can pass a function. Looks like you can't. Yeah, we can't. So we have to do it ourselves. So let's then just do this, and then go through stones, and then we could do heap q dot heap push, and then we're gonna push minus s, right? And now here we wanna get the first and the second one. So this would be x and y, like the problem statement says, heap pop h. Then we want to do a similar one with y, but we want to put minus in front. And then if they are equal, then only if they are different that we do something. If they are equal, then we already removed them and they get destroyed with each other. So only if they are different that we need to put y minus x. So we can do heap q dot heap push h, and then we can pass in minus the difference, which is the absolute value of, we don't know which one is. Actually, since x is, we can either do absolute value and not have to think about which one is bigger, but since x is the one that we remove first, then it's the bigger one. And so we can just do x minus y, right? But to make it simple, let's just do this. And we are doing minus because remember our heap q has the minimum, returns the minimum value. We want to get the max, and so we have minus here. And now we can return heap q like this. Now here, what if it's empty? So I want to do h, if h, else 0. Okay, let's use more example test cases. Submit. Okay, so that passes. The other thing we can do here is, I think this heap q dot heap pop is a little bit repetitive, so we may just have something like pop, just to make it easier for us. Push, all right, and we can actually pass h, x, and then here h, and then this would just return this with the minus, right? And then this will get the value, and we will do this. And then here, instead of doing this, we can just do push without the minus. And then here we can do pop H. This will make it easier to understand, H. And then this will be push with the absolute difference. And then here, this would be, I think, pop. That's it, because we already do minus here. And that should be it. Okay, so we didn't pass H here, we need to pass H. And we can submit. Okay, so that passes. Let's see if there is a slightly maybe better way that other people are doing it. Yeah, I think, yeah, this is a pretty straightforward explanation. Oh, it's just an explanation of the same solution. Yeah, this one seems like it's sorting every time. Where do they push? So pop, pop, and then yeah, they're inserting. Okay, that's bad. Okay. Okay, this is interesting. I see. Okay, this is another way to use heapify, is to convert it with minus x, to convert the list itself and then heapify that. Yeah, I think that makes sense. Also, this is clever. I think this catches a good. I'm not sure if my problem handles 0 there, so let's try it. So what if I do in my console here? What if I do in my test case 0, 1? Okay, this should definitely return me 1. Oh, okay. The problem statement says 1, so he handled it, but it's not really asked here. It's not really part of the problem statement, but yeah, this is clever to handle this use case. Now what is, so we push the two smallest one. Yeah, and we know the first one is bigger, so we can just push the difference, and then at the end we can return H0. But what if it's empty? Can that happen? Unless, okay, let me write it in a really shorter way here. So what we can do is, okay, let's delete this. Actually, we can do this. And now we can, this would be, oh, we need to have it, because we need to have it initialized first, because heapify operates on the parameter and mutates it. It doesn't return anything, right? Even if we take a look at heapify in Python, heapify Python. Okay, so it transforms a list into a heap in place. So in place in linear time, right? Okay, so we can go back here, and what we want is to keep popping, and we could just do heap q dot push and heap q dot heap pop, right? Minus heap q dot. The problem is it will push 0, right? Heap q dot heap q heap pop. Okay, and then here we have h. And then we can return minus h0. But how can we avoid 0 values, right? So since we have negative numbers, this would be the bigger minus the smaller. So we probably need to do minus, I think, here, shouldn't we? Not really, because the values are already negative, right? So this would mean we are doing kind of this already. Yeah, I think, no, we just need to leave it because the values are already negative, right? And so there is already minus here. Yeah, I think we can leave it like that. Let's try this. Okay, let's remove my test case. The heap q is not defined. Yeah, I didn't pass whatever the value. What? Oh yeah, I'm wrong there. Yeah. It's heap push, sorry. Okay, so that passes. Yeah, let's see what h contains for these values here every time. Yeah, so 1 basically each time. What if we have a case where, so it doesn't actually, because we don't have equal elements. So let's try test case with equal elements. Let's try this test case. Yeah, so we do end up with 1 0. Yeah, because we will pop it, right? So because the 0 values, we will pop them anyway. and then with the difference would be 1 0, and then 1 0 would be remaining, right? So that's why it's working. We can see this probably if we print it here in the while loop. If we print here, should be able to see it. Yeah, so first it's just ones. Remember the -1 for the heap. Then it becomes just 2 zeros, and then we return the first one. Yeah, let's do it, and then we can print here the last one remaining. Yeah, so you can see the last one has just 1 zeros because we did 0 minus 0, right? Yeah, I think this is nicer. Yeah, so sometimes you can realize you don't really need to handle this multiple if cases, because one instruction can end up handling both, and this simplifies the logic and makes it less likely to have bugs as well. Yeah, okay, so yeah, we learned something from that solution. Okay, let's see the second one. So the second one seems to be using binary insert. We sort first, and then we do bisect insert. Let's see what this is. Okay, so it's bisect insert. So it inserts x in A after any existing entries of x. Insert x in A after any existing. Okay, basically it inserts an element in the array in the right order, but it does, let's say you want to insert 2 and there are already 2 other 2's in the array, then it will insert it after the 2's that are already in the array. Let's say one of them was in position 1, the other in position 2, then it will insert x in position 3. So with this solution here, we sort the array, and to keep it sorted, we use bisect insert to insert at the right position so that we don't need to sort the array again. Yeah, I think this makes sense. Maybe we can go like this and see an example here. So we have this, right? So let's say I sort first. So let's first say this is our A. And now we sort it. So A is like this. Now let's say we insert 1. Technically it should end up here. So bisect dot insert, and then this is A, and then we want to insert 1, right? Want to import bisect first. So that happens. Now let's say we insert 6 maybe, right? So it's still maintaining the sort order, inserting at the right place. So what we can do there is, let's call this A, just to simplify. So we sort, and then we can do, we want to go through until we have only one element left. So this would be while actually. And we want to insert. So we want to do bisect dot insert in A, and we want to, so for A we can actually use pop, right? So it will return us the last element, right? It will remove it. And the biggest element is of course the last one. The second biggest is the one after it, so we just do pop twice and we insert there the difference. Now we can return at the end. We didn't need to do minus because we didn't add, we didn't change the values, right? So let's see if this works. Okay, it works for that test case. Let's use more. And we can submit. Okay, so that passes. Yeah. Let's see if this one, so this one is using priority queue, same thing in the other one. Yeah, I think that's pretty much the main two ideas in this problem. Yeah, that's it. Thanks for watching and see you on the next one.